Good morning. We are at Felicity International Airport, flying from Budapest to Vienna and testing automatic takeoff and automatic landing. Let's hear the captain.
Folks, very pleasant good morning from the flight deck. Currently,
guys, Delio's on board.
The ship up and get on our way here. I want to thank you so much for choosing United, and also remind you that those three wonderful flight attendants at the back are primarily here for your safety. If you can comply with all their safety instructions, we'd greatly appreciate it. Again, thank you so much for your company and business. We'll be on our way here momentarily. Again, welcome aboard.
Start MC. Not data out of date. That's alright. Database old, but it's good. We can play with that. If we would want an up-to-date one, we would have to purchase one. But for simulation, this is great. So we are clearing the scratch pad and starting the initializing our position, which will be fast initializing, just using the name of the airport, HB. Okay, we can use the gate as well, which is R101. Alright. Route. We can see in the scratch pad LHBP is already included. Just copy this to the origin. I will stop here because I already have saved this route, so I will just load it. So I need to Okay, this is correct. Flight number is 812. We can activate it and execute it, and we have route. You can see that things are coming up here. Alright. So performing init, but before performing init, let's go to the see here fuel waiting plan. This is very important. First and foremost, we have to check our payload. We have enough fuel for this trip, and the takeoff weight is 109,000 pounds. And on the next page we can enter some passengers. Okay, let's see what we have here. Again, this is male, female, kid. So that's 4 males, 6 females, and 4 kids, and that's it. Let's load up some cargo. This airplane is a bit light. Not too many people here. We need some cargo to have more weight and to have a proper balance of the plane. This is important because the center of gravity should be in more or less an optimal point to be more maneuverable, because we want to perform an automatic landing, and maneuverability is important. The lifting and lowering the nose coming from the tail of the plane, from the horizontal surfaces there, and if the center of gravity is way forward, then the nose will become heavy, and we need a considerable forcing backwards to lift the nose. On the other hand, if it is too much backwards, the nose will be too light, and whenever we pull the yoke, we might hit the tail to the ground when liftoff, and we might have other stability problems. Or this can even happen when we apply maximum thrust. Right now, just load up some weight. So we are putting 2,500 in the front and 7,000 in the back, and this will provide us some more stability. This is 7,000. Here it is. What we are talking about is the center of gravity percentage, which is a takeoff weight at this moment 23.6% Mach, and for the landing weight 21.9% Mach. Basically, if we move this point towards this line, the nose will be more light, so this is moving the center of gravity backwards, and this number grows, and this line 26k, meaning that we have 26k force, which is more or less the maximum thrust force from the engine. If we move this point to this line or beyond, whenever we apply maximum thrust, let's say at takeoff, we will end up on our tail, which is not a good idea. On the other hand, especially if the plane is light, there is an influence of the fuel, because the wings have a kind of a delta shape. There are not straight wings, meaning that some fuel is leaning to the back on the wing, and as the fuel is consumed, the center of gravity is coming forward. So you see that there is a slight difference here, and this is a short flight. If this would be a long flight, this green point would be much more further. At this point, the nose of the plane is getting heavier and heavier. If we are going forward, it will be less maneuverable because we need more force. I tried these values below 20, like here it was 19 and here it was around 16-17%. And I noticed that there are some instabilities when the plane is on the glide slope. So Autoland sometimes succeeds, sometimes not. Most of the time Autoland will not work. Therefore, I have decided to move these center of gravity points a bit back. There are two important weights here in this list: the landing weight and the takeoff weight. Next we will initialize the FMC. We have to introduce these weights, or if everything goes well, these might just appear there automatically as we push the button. Let's make a bit more light. We are at the route page. Route was activated. We have active route 1. That's why we could calculate the landing weight, because the computer already knows where we are going. We can perform init. Here comes the gross weight of the airplane. Okay, let's push it. Okay, 130,000 pounds came up. We don't have planned fuel. This is not important in this moment. Zero fuel weight is here. We can use some reserves, like 4,000 pounds. Cost index goes from 0 to 500. 0 is for the most economical flight, and 500 is the shortest possible flight, meaning that we can burn more fuel, we can raise ourselves higher, and we can go with maximum speed. Let's go with 100. Good. At the trip point, there is a proposed cruise altitude. We use a lesser value because it's a short flight. We don't need to raise up so high. 22,000 feet will be right for this flight. And now there are two lines people are debating about. We have to fill in the second line for top of climb outside temperature, meaning that we need to enter here the temperature at the cruise level. So our top of line is at 22,000 feet. If we don't have a real weather chart and we are flying on the computer, we can assume standard values. Hopefully these two lines are linked. So if we assume that there is no deviation from the standard values, which is the ESA deviation line, we can just enter 0 Celsius there and see what's happening. Good. So the computer calculated that if we are not deviating at that height from the ESA values, then we will have probably minus 28 Celsius or minus 18 Fahrenheit at that level. Transition altitude is set to 10,000. And we can execute. Annual limit is the next page. Here, the outside temperature, which is at ground level, is already filled in. We can check that. 17 degrees Celsius, that's right. We are selected at normal takeoff and climb. We can check our route going to the next page. Here we have all these values filled in. This means that we did a good job. Everything is filled in as it should be, and the computer was able to calculate all these intermediary values which are not in the flight plan, like 900A and 6000A. These altitudes were pre-programmed and they are mandatory, and they are in the flight plan. And in between there is this altitude in small font. This is a proposed altitude or calculated altitude by the FMC. Let's see the next page. This looks good as well. We can jump in planning mode. Yes. And check out the route. We have the step button, so we can just follow the waypoints. And we can see in the navigation screens if there are any problems. We are looking for sharp turns or discontinuities, like interruptions. We can observe at this point, this is Badov, flight level 180 below. This is the SID at Budapest Airport. This looks alright. Here it's an important point, top of descent. From this point we will start our descent towards Vienna. And from here we start the transition toward the runway. Let's go further. Here was our top of descent, and from here this is the transition towards the runway. Let's put the navigation screen back to map mode. We can set a heading. It's good to have the heading set to the heading of the runway, maybe around 130. For this runway, it is 127. This is useful if anything goes wrong. We can hit the heading selection. We need to set our cruising altitude, at the altitude back on MCP. Okay, altitude is set. We need to set initial speed. Let's check init page. We can use a bit of a flex, just one. We have to fill in the center of gravity point. Let's push this button. Oh, we are lucky. Center of gravity point is 23.5% for takeoff weight. If we did previously everything right, then this center of gravity value shall autofill. If it's not autofilling, then we might miss something. If it's not important and we will fill this manually, that might work. But this is the best way to see it filled in automatically. We will have a trim wheel level of 4.75. 5 is standard for takeoff. 4.75 is a bit lower, meaning that our nose is a bit light. Well, it's properly right. We have to push these buttons to set lift-off speeds. It is important that these three values are proposed speeds, and we need to confirm them by pushing these buttons. V1 and V rotate will be automatically auto-filled at the primary flight display. We can check that here. Let's magnify it. V1, 1, 3, 4, and VR is somewhere here. So we can assume that from this announcement we can know that the speed band is initialized. Altitude is green. We go back to the takeoff reference page. We have to punch in the V2 147 to the MCP, and you can see that cross weight and takeoff weight was autofill already, which we've seen on the tablet. It's around 130,000 pounds. Let's go to the MCP and punch in the speed. Most of the data is set. Let's check the tablet. There are some checklists and procedures, CDO or SFMC. There is initial data, navigation data, and performance data. Initial data was introduced, navigation data was introduced. We have the position of the plane, the route introduced, performance data introduced, meaning the weights, temperatures, and annual limits, so on. At this point we can prepare to taxi. This time this will be fast because we don't want to waste much time. We will not call the ATC. We can just check up the taxi procedure. Before taxi, these are mostly set, so we don't want to spend some time on this. What we need to do is to set the takeoff flaps. flaps is 1, we have green light, and one takeoff mode selected, and one takeoff limit is set 98.6%, meaning that with automatic takeoff, the computer will speed up the plane around this value, not overpowering the engines. Let's switch off the light and start taxiing. In the meantime, we check here if everything is alright. So we can lower the brakes, and we can switch taxi lights, and we can start taxiing to the runway. So we will not use ATC this time, just save some time. Most important part is coming up now. Right